ethers. So this is a hydrocarbon derivative where you have a carbon bonded to an oxygen, bonded to another carbon. So you've got an oxygen bonded between two carbons. So to name these, you identify which side of the oxygen has the longest carbon chain. So identify the longest carbon chain. This is the parent alkane, and this becomes the root of your name. So the other carbon chain is named with an oxy added to the end. So identify the length of the other carbon chain. Remove the ANE portion of the alkane name and add oxy. Add the term oxy. So if the smallest portion is ethane, it becomes ethoxy. And this shorter chain is added as the prefix. Now there is a number associated with this prefix, and the number is identified by or determined by the carbon it's bonded to on the root carbon. So you've got to look at where that O is on the main chain. Do an example here. 1-ethoxy propane. So what this means is we've got a longest carbon chain of 3, and attached to that is an ethoxy group, or is a 2-carbon chain. And the smaller chain is attached via carbon number 1. There could also be 2-ethoxy propane, and what that means is our longest carbon chain is 3, but the 2-carbon attached to the oxygen is attached to carbon number 2 on our propane. So this would be 2-ethoxy propane. So the ethoxy comes from how many carbons are attached to the smallest carbon chain. The prefix comes from which number in the other carbon chain the O is attached to. And then the last portion is how long is the longest continuous carbon chain on the other side. Now, there could also be side groups on the main part of the root, or the main carbon chain. So, if there are side groups, on the longest carbon chain on the root, these are also prefixes. And you also have to include a number with them. However, these prefixes attached to the root portion of the name. Let's try and name this. Here we've got our functional group, a C with an O and a C. So there's our ether portion. Here's a small portion, so that's our prefix, and that means this is our longest portion, the main part, the root, and there's a methyl group as a side group. So there's 5 carbons in our longest carbon chain, so that portion is called pentane. And it has a methyl group on it, so there's a methyl pentane. And to identify the carbon that the methyl group is on, you start counting from the O. So we've got 1 carbon, 2 carbons, 3, 4. So this is 4-methylpentane. That's the longest portion of our carbon chain. And then this final portion is the very first prefix, and that is our oxy group. There's 1 carbon, so it is methoxy. So this methoxy group is attached at carbon number 1 on the main chain. So this is 1-methoxy 4-methylpentane. So let's see if you can draw 2-methoxy 4-methylpentane. 2-methoxy 4-methylpentane. So the oxy portion tells us that this is an ether. The last portion of the name tells us that it's 5 carbons. So it's 5 carbons. There's a methyl group on carbon number 4. And carbon number 2 is where we join the other carbon length, the other part of the ether, and we have a methoxy, so it's only 1 carbon long. So 1 carbon attached to an O, attached to the second carbon in a pentane with a methyl group on carbon number 4. So all you would have to do now is add your H's on to the rest of the carbons to give each carbon 4 bonds. Drawing them, find the root, draw out the carbon chain, look at prefix to identify and place the COC bond, then add any other prefixes or side groups or appropriately, of course. Add the oxy group. Fill in the rest of the H's. Alright, let's practice one more. 3-propoxy 4-methylhexane. So our root tells us that we've got 6 carbons. It's got a side group. And the other portion of the ether is 3 carbons long for prop, and it's attached to the hexane on carbon number 3. So we've got an O attached to carbon number 3 on our hexane. 1, 2, 3, 4, 5, 6. So there's our longest continuous carbon chain, 6. This is carbon number 3. And we've got a methyl group on the 4th carbon. So 1, 2, 3, 4. There's our methyl group. So there's our methyl hexane. And we've got a propoxy, so a 3 carbon on the other side of the O. So now put in your hydrogens. And there is your ether. Physical properties for ethers. They are only slightly polar. They're bent at the O junction. That's the Vesper shape. So we've got London dispersion forces and dipole-dipole for the intermolecular forces. So they have weak forces of attraction, so they have low boiling points. If your carbon, if the number of carbons is between 2 or 3, they are gases. Higher than that, they're liquids. In terms of solubility, carbons 2 to 3 are soluble, but above that, only slightly, and they become insoluble in water once they are 7 carbons or higher. They can accept hydrogen bonds at this O, but they can't make them. So therefore they're a little bit soluble.